too hard to realize. I see through the smile that you're faking. You're so into yourself. Everyone else is overrated, and everything's changing. Is your heart worth breaking? 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 Is your heart worth breaking?
Uh, okay, what's up, guys? I hope you can hear me. Also, acknowledge with a thumbs up if you can hear me. Alright, guys, if you can hear me, just put up a thumbs up or something, anything. So at least I'll have an idea that I'm pretty audible. Alright, anyways, guess I'll just start off. For the ones who end up coming later on, you could just like, I guess, go through the video later on. Hopefully I'm still audible. So, yeah, right. Alright, cool. So basically this is gonna deal with the use of shader graph this entire session, and that primarily involves shaders. Like, as you already know, materials have shaders, right? Each and every one of these materials has a shader over here, which is the part which actually tells the material how to respond to light and to certain effects. So the basic shader version that you have, that you end up getting by doing this, you do this and standard surface shader, that's the kind of stuff that you have to code out completely, and that's done in HLSL, I believe, or GLSL, I'm not very sure, but either way, the point being that kind of stuff is slightly more complex, and it genuinely requires a completely different skill set of understanding shader code, all of this. uh, to be fair, most of the actual game developers don't really know this by themselves. There are separate programmers who know this and are well versed with it. So this becomes slightly tedious for most people, and hence Unity ended up bringing up another option, which is called shader graph. So what you should do is, like, for the beginning, just open up Unity Hub. All right, and when you end up adding a new project, okay, you can't do this in your previous one because my assumption is by default you have it in just 3D. What you have to do is you have to select lightweight render pipeline. So each one of these Unity projects has its own rendering pipeline. The standard one that it has is one which is applicable for these three, and there are two others. One is lightweight render pipeline, which is LWRP, and then high definition render pipeline, which is HDRP. HDRP is supposedly for more console level games, like really high fidelity, good looking stuff. And lightweight is for, let's say, mobile devices, and for, let's say, budding independent game developers who are still getting used to it. So if you create a project under that, you will get something that is like this. This is your initial sample scene that will pop up. So we'll just create another scene and save it. This is your default. Turn off this. Nope. Yeah, this is okay. Right, so this is the standard stuff like usual. And so let's just set up like a small cube. This one, it's like 25, 25, oops, my bad, 0.25 and 25, cool. Right, so now, right, so this is your basic scene. Now that's your surface. Let's just create another 3D object with the item over here. We bring it closer. So that's your cube, and that's your camera, right? So as you can see, now over here, this is your default skybox material, so I'm not going to mess with that. Now, usually what you do is you would create a material just like this, right? You click a material and it ends up picking the standard shader. In this case, for lightweight render pipeline, it just picks the appropriate one, which is lit, which is influenced by external lighting sources. So if and this is pretty similar to the one you've seen earlier. It's slightly different, obviously, the layout of it, let's say. So let's say I want white here, and then I just dump it onto this. It's the exact same in that aspect, at least. Now, suppose I want, let's say, a hologram kind of effect on this, yeah? So one of the ways to approach it is by using shader graph. The other alternatives you have is going to the asset store, and there's a thing called Amplify. Amplify is a third-party extension which you can basically import into Unity and use. It has very similar functions to this, and the benefit being you can use it in 2017, 2016, like much of the older ones as well. So you could use that as an alternative. That's slightly more flexible and well developed, let's say, and more supported also. But shader graph is going to become the new norm, so it's just better to learn this through and through. So yeah, to do that, step one, you have to create the shader. You don't just start with the material. So you go to create, you go to shader, and instead of your usual standard surface shader, you select PBR graph. Okay, that just basic name's fine, that doesn't matter. So this is your PBR graph. It looks the exact same as your standard shader, but when you double click this, what you get is this. This is a new window that you would not be accustomed to usually. So yeah, this is pretty much the exact same thing as your standard, once again, yeah, as your standard layout. So in terms of, this is your PBR master, this is like your basic control, and this is what everything that you end up putting on the left hand side plugs into this, because these are your main parameters. All of these can be controlled by some other nodes, which you end up getting by right clicking. You can do create node and this, or I believe you can just press space and get it. Yeah, so you could do either of those. So albedo as usual just gives you the color, as you can see over here as I change it real time. So that's that. Normal, as I've already told you, emission in case it's an emissive material, and metallicness, again the value can be controlled. Oops, I'm not, yeah, it can be controlled. Smoothness precisely the same, occlusion also. All of these are values that exist by default at some value, and this you can control with something else. Now, the thing is with shader graph, okay, what I could do is, yeah, I could just show you that much, right? The thing is, if you have certain items like, let's say, okay, so initially at least we need a few parameters that can be controlled externally. If we don't have any parameters controlled externally, then what you have to do is every time you want to change a value for the final material, you have to come here, you have to change a number, like physically end up typing out 1 2 3 etc whatever, and then you have to save it over here, save asset, and then go back and blah blah blah, which is annoying. So usually what you'd end up doing is you click over here, you select any one of these. You could consider these as data types, let's say. These would create a certain thing. For example, let's go with color. We'll need a hologram color anyways, so hologram color, you know. So yeah, this is something we have. So let's say its default is given as this reference number, which you can use for plugging into your script, which is not particularly good at this moment, but okay, anyways, it's fine. So you can just take this and you drop your variable over here. I mean, it's not called a variable, but anyways. So your default color is black, right? Now you just plug it into your albedo by default, and it's black. Ta-da! Now suppose we save an asset. This currently is exposed as a variable. So when you create a material, yeah, for creating a material, you can just create a material like this and then go and change the shader over here, or you could just right click on the shader itself and then create a material. That by default assigns it to that. See? And here you can see hologram color, because that is a parameter that I left over here. So it's exposed, as you can see. Turn that off. Close it. Go over here. You can't see it anymore because, obviously not exposed. So getting back, exposed, that's fine. Right, so let's get along with it. So we need a hologram texture, right? Or a hologram shader. So a hologram, as in we're gonna have like basically like lines across the entire thing, and they just keep scrolling up basically like at a very slow pace, and it's emissive because it's kind of glowy. So right, so first of all, first things first, we need the thing to move, right? Obviously we need the lines to move upwards, so that would involve time to pass. So first thing we do is select time, right? So we have the following options. Delta time basically takes it with the frame rate of your actual game running. Smooth delta time, depending on how choppy your game is running, it smooths it out accordingly. Cosine, literally a cosine. Actually, that's not cosine. Wait, yeah, that's cosine. Sine, and then time just takes it linearly, basically. So going by that, now what you'll also need is the texture to tell it that you want these horizontal lines, right? So obviously you want to be able to change the texture by itself. So we do go over here, we take texture 2D because it's a 2D texture, right? And we end up selecting that. We say, I don't know, hologram texture 2D. Hologram texture 2D. Cool. Now going by that, we have time. Now we bring this down. We have a hologram texture as well. Here there's no default being given, which you can actually add it. Let's just say, yeah, you can see these look horizontalish, let's say. I mean, it is horizontal, so that's your default as of now. Right, so these are the two things. Now what you want to do is you want to multiply the time flow with this parameter so that it progresses forward, right? So what you do is you select math, I believe. No, math isn't a thing here. Multiply, yeah, multiply. You select multiply, get it over here. This gives you like a slight preview of what you're trying to do. So you just plug this over here, and we select, oops, my bad, plug this over here. That does not seem to be plugging in. I may be doing something wrong. Just a moment. Sample texture. I think you have to do sample texture. Yeah. Yep. Yep. Okay. So you can't really plug in a texture 2D directly. You need to put sample texture first. So as you can see, this is the image that is the default. So we take the RGB value of that and we plug it here. We see this. Not particularly fun, but I mean, hopefully this leads to something good. So as of now, let's just proceed. We have this. What we can do is we take tiling and offset. I guess we could take tiling and offset, which would, obviously tile it and offset it. So we take this one's output, we dump it into offset, since that's what we want to do. We want to offset it, right? I believe this should not look this way. I'm not very sure. This may be wrong. Does not seem to be the right way. 1 second.
A really cool effect that is
1 second. The base color is fine. Yeah, it has to be a texture itself. But adding a texture by default seems to create issues. Sample texture. Yeah, it seems to be right. Nothing wrong with it. As of now, at least. No, maybe I could just plug it into. Just give me 1 second. So let's say we plug it into the alpha. Don't really see anything over here because by default it's in opaque. See, so we do transparent and it's completely gone. Two-sided. Maybe the material isn't exactly appropriate for this. Actually, the texture isn't appropriate for it. What we could do is change that. Yeah, actually, this works more. There's no alpha parameter in this, so there's nothing to scale it accordingly. Should have gotten an actual. Oh, this kind of works. Kinda, not too well. Okay. Yeah, you can move it. Like you can see it. These lines, it's kind of faded. I don't know if the video compression is allowing you to see it at this point, but yeah, you can kind of see it. So you kind of want this. This is not hologram exactly, but like as of now, it's going to the alpha, right, as the albedo. So maybe I could add it into the emission and it may work. Yeah, kind of emissive. It's not really visible, but kind of. So just as an example, I can just save it and just apply it to something and then you get an idea. This is the same material, right? And new shade graph. That is white. Okay. This is the thing, right? Yeah, there you go. See, it's really transparent. I don't know if you can see it. Actually, what I could do is, if I end up downloading a thing, hold on. What would it be? Hologram texture, let's say. Yikes. Maybe I could use some of the older folders. Just give me 1 second, because if you don't have the right texture, it doesn't really look that good, so it just kind of ruins the point of a hologram. Hologram. It needs to have a certain alpha value as well with it. So decal, nope. Yeah, okay, fine. I guess we can work with this for now. Yeah. So okay, fine. Anyways, we can proceed with this. Yeah, we need tiling offset. I'll keep multiply for some other time. We do need time. And alpha remove. Yeah, it doesn't look as good at this point. We'll keep alpha. Is it gone? Yeah. Remove this. Cool. Also we have like a base color, right? Yeah, that's connected to albedo anyways. That's fine. What's the base color? It's black. So maybe make it red. Yeah. See, now it's kind of visible. Slightly more at least. Make it red. It has a reddish tint. Okay, just keep that for now. Besides just this, we could do another thing. We have this, right? The other thing is we have another UV over here. So what we could do is connect the tiling and offset to this. And if I'm not wrong, if you scroll along this, see how that moves? Yeah. The issue being it kind of, let's say, stretches and squishes the actual image, which is not excellent because towards the end, this is what starts happening. It stretches out a lot and looks like absolute crap. So what you could do is instead just offset it. One second. That's because I was manipulating the tiling, which is not advisable. Instead, you want to manipulate the Y. Yeah, see? If this just proceeds at a normal pace, this is what happens. This is your very, very basic hologram. Not particularly good looking, but basic. If I'm not wrong and I stick this here, it should do something. Excellent. Just not very good. There is another way of controlling this, but as of now, we'll just delete this. We're not going to use this. What we could do instead is we could go with the texture is over here. We have we could have a vector 2 hologram tiling. You may want to control the tiling. I know I spelled that wrong. I'm sorry. We control the tiling with this, and by default it's 0 0, so it won't show up. Yeah, there you go. Save the asset. That's your default tiling, and this is your time. So what you may want to do instead is you want to control the speed, right? You want to control the speed at which the thing is moving, the hologram. So you do a vector 1, we do speed, we bring that down, right? We have these two things. Now you want to multiply the time with the property, which is speed. So let's do multiply now. Hopefully this works. So we add speed at the bottom and we do time on top, and this we stick into this. Not really doing much. Maybe the speed. Oh yeah, speed by default is that. Okay. Oops. Hey. Yeah, now it's offset in an odd way. So what one could do is we could basically have, let's say, screen position because we want it accordingly, right? The issue is like if we move it, it kind of looks odd. See, it's kind of going to the center, which is odd, just to say. So instead what I could do is we could use screen position. So what that does is irrespective of your screen position, it will keep it locked. So you end up seeing it as horizontal in spite of what angle you may be viewing the object from. So for example, you can see it in the background already. Yeah, see? Now that's way too fast, I know. So we could just slow the thing down a bit. Where's it gone? That's tiling. Speed. 0.1. Yeah. Now, since it's on screen position, see how I move it? You can just like, it'll always be entirely horizontal, no matter how you look at it. Which is kind of what you want from a hologram, right? Depending on, of course, what you're going for, what kind of look you're trying to achieve. So let's say I want it as red. Maybe I don't even want the directional light. I might need it. Yeah. Maybe turn on the skybox. Yeah, could do that. Just darken it. Cool. So yeah, you can see this. Obviously, also in the game, it won't be running right now, but the moment you play it, it starts happening. See, there you go. That's definitely not a hologram, in case you're wondering. It needs to be much cooler looking, first of all. So that again, honestly, to an extent, that just depends on what you end up adding. But this is the basic makings of a hologram. Now, just to do that, the thing is, most of the time the hologram ends up being brighter around the edges, right? So one thing you can do to fix that is, instead of just a standard color over here, we could add an HDR color. Do we have HDR? No. Color, it's not HDR. I think you can. Yeah. Cool. The color I have over here Yeah, actually, just remove this. We convert this to HDR. So then the HDR ends up giving you a few additional. HDR stands for high dynamic range, first of all. So what it does is, even in spite of this being white, it could look a little dull, right? So you might want it to have a higher intensity. The HDR allows you to have a more contrasty image, let's say. So it punches up the okay, not vibrancy, but contrast, yeah. So it gives you a more accurate looking image. So see, in spite of the thing still being 255, 255, 255, as I increase the intensity, it actually becomes much brighter and darker, respectively, while simultaneously remaining white technically. So I'll just keep that as 0 as of now. I don't know, let's go with a red hue and maybe slightly brighter. Yeah, let's make that 2. Cool. Save that. That's that. Now the thing is, most of the time these holograms are brighter around the edge, right? Slightly less through. So you can see through it much easier, but like towards the edge it brightens up a lot. That effect is known as Fresnel. So it's spelled differently than you think. Fresnel, but yeah, it's Fresnel. So yeah, as you can see, it's brighter around the edges and much darker towards the center, and that you can control with the power over here. So for the power, again, you could just have a simple float 1 over here. Sorry, vector 1, and it'd be power. By default, it's like, let's keep it as 2, I guess. Stick that out and connect it. So all of these, the benefit, as I said, all of it is exposed to the outside, so you can just control it from outside. Now, besides that, we need to multiply this itself with the hologram color that you've chosen. So again, actually not just Control C, Control V. We do this, plug this in, and we plug this in. So yeah, as you can see, this color is red and this Fresnel effect. So the center is dark and the edges are much redder, which is the color I've chosen over here. I make it, let's say, teal, for example, and it goes to that. It still doesn't show up here because I haven't plugged it in accordingly. See, it's a little darker over here. That's because of the power value that I have. I could just change it to, I don't really know what, 5, let's say. It's much darker. Let's say white. Yeah, 1. So that, what else could be done? Yeah, I guess that's that. Yeah, you can control that externally. This is fine. Yeah, so as you can see now, like the edges are much brighter over here. And again, this doesn't have global illumination double-sided. I don't think that works. Yeah, that. So this depends on honestly what texture you end up putting. You'll have to look accordingly and add it. Oh yeah, this looks weird. Just remember your image needs to have some sort of alpha value, like as I've explained before. This would look really odd. Yeah, that's because like all of this black portion you see is like transparency of, it's like completely transparent, and the white portion is the actual image. So as we reach the center of that, it ends up being showing up more accurately, same as this. So the central darker portions are more transparent, whereas the light white patches that you have here and there, those are what show up as bands. uh, yeah, same for this, the black part of it is transparent. Yeah, so again, this is basically what you'd have for a simple hologram effect, you know. Maybe a cube, tile cube, I don't know. Anyways, maybe we could use this. This looks terrible, but yeah. So we could increase the tiling, as I said before. Just change that, change the speed maybe a little faster. Yeah, so basically you can get a lot of effects. As of now, it's showing up over here, but it doesn't always show up in real time. Sometimes you just have to play the game. Change the power so you can see how it, okay, yeah, oops, that's the inverse of it. So the center is really dark and the edges end up becoming, sorry, the center is really bright and the edges become really dark, and vice versa. You could change the color, as you know. Yeah, so that's your basic little hologram shader. Again, this is, it's like you just have to play around with this a lot and come up with new effects, or you could just do like a million tutorials on this. because it honestly boils down to what you end up putting. For example, you could just add two sample textures and have them overlapping over one another. So in this case, it's going in this direction. You could have one that goes in this direction and overlap. So it looks like, I don't know, two of these holograms simultaneously. Could look cool. Could look cool. Yeah, I'm actually curious. If I stick it here, what happens? Nothing really. Eh. Alright, so yeah, that's the shader graph part. Whoa, okay, that looks very different. Anywho, so that's the shader graph part of it. Actually, it's taking the yellow color into consideration. So if instead of that I put red, looks kind of orange. Okay, that looks pretty cool. Hate the color combination, but yeah, anyways. So that's the shader graph part of it. You just have to mess around with it to understand it, figure it out, etc., etc. Besides that, what thing you could do is, yeah, so of course, shader graph is itself. And the other thing you have is enemy AI. As of now, what you had is just a simplistic. I mean, you actually haven't been taught how to make enemies, right? So, yeah, this secondary one will just have a standard little mesh. Okay, these are both cubes. Let's assume cube 1 is your player, and this is your enemy E1, right? Let's say this one's material is like a normal. Cool. So the cool one's you, obviously, the odd one, and this is the enemy. Just for the sake of ease, I am going to make this go a little further. Whoops. So you can see what's happening. Yeah, it's cool. Right, so the player script already exists and it does not exist in this scene, so that would be annoying. So I'll just make a really quick one. We have scripts, right? Yeah. So player, yikes, that is badly typed. Good lord. Player, open that up. So that's your player script. You'll just have, not gonna animate it or anything, we'll just have standard public vector 3. Whoops. Oh good lord. Public vector 3 move direction, and we'll have a public float speed. Cool, those two things. We don't need anything in start, like this. And in update we'll have float edge equals input dot get access. This is stuff we've already done, to be fair, but I don't know, recap I guess for you guys. Not even copy pasting it right now. Could do that. That V and vertical. So, oops, move direction x. Move direction is equal to new vector 3 h comma 0 comma v, because we just want to move in x and z, and then transform dot translate. I'm using a non-physics based movement here. It's just easier in this case. Into speed. There we go. Yeah. Yep. And just to test it out, player speeds 0.5. Yes. Please don't fly. Okay. Yeah. Cool. So I can control this, as you can see, and it looks pretty cool, especially with that shader. But yeah, you can pass through this for some reason. Oh yeah, they don't have a rigid body. Just for the sake of it, I just add a rigid body. You don't have to add it just for, let's say, rigid body movement. You tend to add it because you want collisions and any sort of gravity affecting it. That's why you add it. So yeah, we have a rigid body on both. This means this time they'll collide and I can push one with the other. See? Cool. And that also changes my rotations. It messes it up quite a bit. Okay. I'll just lock the rotations. Constraints. Cool. So we have player movement, obviously. Now the enemy is currently boring as shit. It just stays. And that is not a fun game. So what you could do for that is basically come here. No, wait. You have to create an enemy script, right? Enemy. Open that up. Right. The player is fine. That doesn't matter. So what you could do is, yeah, you could use transform the translate itself. Doesn't matter. One of the things is obviously it needs to know. I mean, step one, obviously, to follow your player, it needs to know where your player is. So we need a yikes. That's a lot. Which one is this? Yeah, this one. So it needs the player, right? So what you do is we end up adding a player thing. So let's say public game object player. That's a player. We need a speed for this thing also. So public float speed. That's a speed. You want to have it rotate, right? So we'll have to have spin speed. So rotate at a certain speed. And what else? It needs to have, okay, as of now we'll just add these two and then I'll show you accordingly as we go along. Yeah, right. So here what it needs to do is it just needs to rotate towards the player, right? So one thing you could do is, I wouldn't really suggest this, but anyways, transform dot look at is a function that literally does what you think it does. It looks at the thing, looks at whatever you end up putting inside. In this case, it looks at the player's transform. You have to add player.transform because here the player is a game object. If it was transform player, then you could just put player. And transform.lookAt means it's this.transform. It's the exact same thing. It controls the transform of this enemy object. So it'll look at the player and simultaneously wanted to move towards it, right? We just do this. We do this. And now since in this case, with this line, it is already looking towards the player, all you need to do is move forward. So you don't need to know the move direction and stuff. You just do transform dot forward, which is the forward vector for that current object multiplied by the speed, which should work, hopefully. Yep, it does. So I did not add it. Yeah, okay, let's add it here. Right. Now, in this case, we are dragging and dropping the player into this game object, right? Sometimes that is not a good idea because you may have like a gazillion of these things, and even though you can prefab it, it might become a headache. So there is a way to just programmatically get the player by default. So you don't have to drag and drop into each prefab, which I'll add in the next one. So just before that, we'll do like 0.25, I guess, and spin speed of, I don't know, 5, I guess. I don't know. This may or may not work. Yeah, as you can see, it just follows my ass all throughout. I do not know where the player went. Oh shit, it fell down. Okay. Yeah, so it just follows the player all throughout, and it fell off again. Good lord. So yeah, that's that, and it's moving too fast. I could just slow it down a bit. 2 and 0.1. Make the cube a little bigger also. Yeah, should be a little easier to control. Yeah, so it goes around. What am I doing? Oh shit, that's not WSD. Okay, see, goes, that's its forward, like in this direction. For it is forward. That's why it ends up swinging all around and doing this, which, as I said, I would not suggest. See, it just tends to go a little further than you, swings all around, and then here, as it comes, it will start moving forward. See, that's why I wouldn't really suggest look at that much because it's a little tougher to control. So instead of look at, what thing we could do is there is a way to directly control the rotation of the object. So what we'll do is we'll create a new function called rotate to player. Whoops. Yeah, rotate to player. rotate to player. So what you do over here is you can initialize just with a var over here. So it doesn't really matter. Not all the time, but yeah. So look position. So you need to know the position in which the enemy needs to look, right? So to do that, you have to do the player dot transform dot position minus transform dot position, which is the enemy's transform dot position, and I spelled it wrong. Transform, yeah, transform dot position. So this is in the form of a vector 3, but you don't have to really set it up over here like that. You can just do this. It's the same, slightly smaller. So what you want to do is, like in this case at least, in this game, we don't want it to move. Okay, whoops. We don't want it to move in the y direction. We don't want, in case the player ends up jumping, I don't want this to look up at the player, right? For some reason. I mean, actually, the thing is, for a cube, you don't want it, but let's say it's a physical human being over here, you could have that kind of script which breaks down your limbs and your head into separate parts. So you want the head to look up, maybe, but not really the entire body. So for that, what you could do is you go here, yeah, and look, pause, you take that and dot y changes y value to 0. So it just remains at eye level, let's say, for it all throughout. Then you end up converting the rotation of this object, rotation equals, and as I said, you have to use quaternions when it comes to rotations. Quaternions, and quaternions are a nightmare. Please, I mean, you could try learning about it, but it doesn't really matter. It's a nightmare. That's honestly the only easy way to explain it. So yeah, quaternion basically converts it into quaternions. Look rotation is, look rotation. It's the angle that this object has to spin to look at this current position. So it's, let's say your object is, I mean, I have no clue how to show it, but assume your player is over, your enemy is here and your player is here, and let's say the player goes over here. So forward, and the player is here, and so this is your new vector, and this is the vector. So this angle is what this rotation will be. So what you need to do is you need to move from your current rotation to that new rotation, right? So what you do is transform dot rotation is equal to quaternion, because again you're dealing with angles. I hate the spelling of quaternion. Dot slurp, SLERP, which I am not really sure what it means, but lerp is linear interpolation. S is, I don't know. You can just use lerp. It doesn't really, I could, just to prove a point, you could just use lerp like this, but as of now we'll go with slurp. Oh yeah, sorry, smooth linear interpolation. Damn it. Okay. It smooths it out, which is usually good for rotation, because otherwise it will be quite janky when it switches. So yeah, going with lerp like this. If you guys have any doubts, you can just ask it. It's fine. Transform dot position. No, you need rotation. Right, sorry. Transform dot rotation. From your current one to the new one, the rotation. Current one is this, and new one is this, and you want to do it at a certain rate. So you do time dot delta time. As time progresses, you want that rotation to build up, and multiply that by spin speed, so it rotates at a certain pace. So instead of this pointless little thing, you use rotate to player, and you do this. Hopefully this works a little better, at least. Everything else is fine, right? Yeah. Oh boy. Shit. Okay, the power went just. My bad. Let's hold on for a sec. I can't. Actually, I can see it. To be fair. Right. Anyway, so yeah, this looks a little buggier than it should be. I do not know what it's doing. Okay. Yeah, my bad. The power had gone, so it's kind of choppy also. I'm trying to understand what it's doing. It's a little weird. No, wait. It is following it, so I guess that is fine. I don't know what's wrong. Maybe it's the transform.forward issue. Yeah. So what you could do is, this is your thing, right? Yeah. So, right. So as of now, the rotation part seems to be fine, but moving towards the player, not so much. Oh yeah, about the player thing. So instead of just adding, dragging, and dropping it every single time, there's a function for this. So what you could do is, it's called player in this case because I've named it player, and it's called game object. Oops, game object dot find game object with tag, and then you put player inside this find game object with tag. So what this does is it automatically assigns the player even if you as a user haven't done it, or developer I guess. So in this case I have assigned a player over here, so let's say none. So suppose I haven't really assigned it over here by default. So what you do is you go to the tag and you have player here. You can add a separate tag depending on whatever. Fuck sakes. Okay, power went again. One sec. Yeah, so you can add other tags, but as of now the player has a tag of player, and this is looking for the tag player. So by default it ends up assigning it over here. Oop, see, picked it up by default, and it's chasing it. I think the movement part is a slight issue as of now, so we can work on that. So similarly we'll just have another function for the movement part, call it move to player. Move to player, same thing, and instead of this you do this. Right, so for this let's go with you need to know the difference between those two. Now the other thing is the issue with where's it gone? Oh shit, I deleted. Using transform.translate has an issue because by default transform.translate literally implies that you're teleporting your object. What you're doing it is you're giving it new positions every frame, which would cause it to sometimes, not sometimes, very often actually, skip completely through solid walls and objects and stuff. That's why you more or less have to use rigid body in some way or the other. So I could show it to you, but yeah, actually I could show it. No. Did I actually change something? Yeah, shit. Okay. Yeah, we'll just call the okay. Wait. Transform dot translate. Transform dot forward times speed. Oops. Yeah. Cool. And I'll just close this part of it. Yeah. Now we add another box over here. Cube. Okay. Stretch this out. Take your enemy and dump it to that side. Actually, I'll have the enemy on this side. Cool. Now, once I play it, what you can see is it will. Yeah, in this case, it doesn't seem to be fast enough. That's why it won't really happen. But most of the time, if you speed it up a little bit, like let's just keep the cube at increase the height a bit, I guess, so it doesn't jump through it. I mean over it. Let's say you increase the speed to 0.5, I guess. See, it just went through the entire wall, and it just goes through it casually, completely. And of course, the behavior is not very accurate, I'd say, but yeah. So point being, if you don't use your rigid body sort of movement and you just use transform or translate, it's definitely not really good. So that's why I suggest using a rigid body movement most of the time, physics based one. So going by that, first thing you'll have to do is have a rigid body mentioned here, right? So we need a private rigid body. Of course, again, it could be public, doesn't really matter. You could drag and drop it, or since in this case it is a component on this object itself, you just refer to it. So what you do is RGB equals get oh shit, my bad, component rigid body Shit, I spelled it. Good lord. Okay. Component. Yeah, so you get the component, right? Now for moving the player, what do you need to know? You need to know the player's position, right? So I guess look pos is fine. Player.transform.position minus this one. So we need that. And what instead of this, what you do is we do, as we've already mentioned, there's a thing called RGB dot add force, right? So you could do add force, and add force, and we need to specify a particular direction. So we do your standard transform dot forward times speed. Okay, this is your basic direction in which to move and speed. Now there are different types of force. So you have force mode, you have impulse, in which case it just, I mean, you know what impulse is. It literally gives you a force in the form of an impulse. Might be useful in the case of a gun, let's say, or a grenade explosion. You just want to give it for a split second, right? Just like a boop, and it's done. That's it. But in this case, you need a constant change or a constant force that's being added to this. So for something along these lines, you would need, let's say, a velocity change. So we have force mode, velocity change. I do velocity change. I missed a semicolon. Oh, oops, my bad. Yeah, so that works. It'll pick up the object by default. Everything else remains the same. The speed might not be sufficient considering it's taking its mass into consideration. So let's see. Yeah, now see, it's just there. It actually respects the boundary of the wall. Wherever I go, it's rotating accordingly. It's pretty smooth because the spin speed is really low. So I come here, things following me, and I have no clue where it went. Why are you doing that? And it fell down. Excellent. Maybe increase the spin speed to like 15, maybe 20 even. Standard speed to 0.25 should be fine. The issue is more often than not, the place where you'll go wrong is the transform.translate part. I'm sorry, the transform.forward part. Yeah. Hey, excellent. This is not. Okay, so just for the sake of it. Now that I've, okay, yeah. Even if you increase the speed of it, where's it gone? Yeah. Enemy. I could make the speed, let's say, 5. Theoretically speaking, considering I put collision detection as continuous, what it should do is constantly go and check the collision. So if I end up playing, what it should do is not go through the wall. See, in spite of being really, really fast. So I could dump it here. Your player's beyond this wall, right? You play, and it just smashes against it. That's it. Doesn't go through it. Just gets stuck because it's respecting the physics of the actual object and the enemy. So going back to a smaller speed of, let's say, 0.1 and turning the cube off, you can actually see the enemy chase you. Why isn't it chasing you? Yeah, okay, I think the speed is too low. It's still too low. Oh yeah, I have it done. Yeah, velocity change, right? Yeah, so at this pace you can see how it kind of slips and slides. See, there's a slight bit of drag that just stops it and it curves, which makes it look much more realistic. Unlike the movement of the player, which is like rapid. I can immediately move to wherever I want, which isn't particularly realistic. So it honestly depends on the kind of game you're making. For Mario, for example, you would hate putting a rigid body thing. You have to take your momentum into consideration and stuff as a player, which is not good. So for an enemy, this does look pretty chill. So yeah, that's your basic enemy AI. You could juice it up quite a bit more by adding stuff like, I don't know, a target radius and stuff. Like only within a certain radius will it get activated, for example. So it's relatively simple. It shouldn't take too long. It is basically just boiling down to taking the difference between the two of them. I'll need the target range then. Target range, and let's say angle, these two things. So when we do this, it has to check it at everything. So move towards player. It does now. As of now, it just moves towards the player. It is irrespective of what. So here, what I'll do is first I'll try to get the distance between the enemy and the player, right? So we do vector3 dot distance. We end up putting the position of two of those. So we say player dot transform dot position, and then we put transform dot position. Oh, good lord, what have I done? Transform dot position. Okay, player dot transform. Yeah, this is fine. These, it gives you the distance between one of these and the other, and so after this, what you do is you need to check whether it's within limits, right? So you check whether it's less than target range. Ta-da! Then you open the bracket, and accordingly this. So only if it's within this range does this get activated. Hopefully this works. Position doesn't exist. What? Makes no sense. Transform dot position. What? 31, right? Player dot transform dot position and transform dot position. What? Oh yeah. Oops. My bad. Cool. So let's put target range just like 5, I guess. And just for the sake of it, we'll keep the player a little here, enemy there, right? Add the main camera under the players. As the player moves, you can move with him, right? So by default, our man here is looking. The enemy is looking at the player, but he won't charge because as of now, he's out of the radius. Once we enter the radius, it should technically start chasing us. Why do you not chase us? Why isn't it chasing us? I do not know. Oh wait, wasn't the velocity too low initially? Yeah, it was 2.5. No? Oh yeah, it is that. See? Starts moving, starts moving, starts moving, starts moving. And it stops again. That's, I mean, again, depends on the target range. Now in this case, let's make it 15 and I'm going to make it 1. It's going to fly really, really hard. So I'll just increase the drag a bit. It may see the player, I'm not sure. Okay, it doesn't. Okay. If I come a little closer, you can look here or there. Runs to the player. See? I'm out of its view. Technically, it's radius, so it can't move. It's still looking at me because I haven't coded it correctly. And it spins again. Misses me. So then the other thing we could do is, instead of just this much, instead of this actually, what we could do is you dump it here inside update. And then accordingly, you end up doing this. So only if it's within that target range, does it actually look towards the player and then move towards it. Both. Oops, 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 oops. Right? So it does both. As of now, he just looks towards the player like a creep all the time. So we have the distance part of it set down. The next step would be to get the angle, right? So what we do is float angle to player, I guess. Yeah, angle to player is equal to vector3 dot angle. Now it has to be forwards from something. So we're taking transform dot forward, which is from the body itself. Two, you need to know the direction in which you're trying to look at, where your target is, right? So you got target dot transform dot position minus you do transform dot position, transform dot position. So that gives you the direction of that. So it's from this point, which is transform dot forward, which is this vertical, assuming your enemies here, it's vertical, and target range. No, it's just target. Oh, it's actually player. No, oops. Player dot transform dot position minus transform dot position. So that will give you this direction vector. So it's the angle between these two, and you have to just normalize that. Otherwise, its length gets taken into consideration. Normalized. Cool. So that gives you the angle. And again, we have another condition that actually no, just a minute. we say if angle to player, god damn it, angle to player is less than angle, as in if it's within that angle, then rotate and move to the player. Should work. Now this part is usually a bit tricky because the angle isn't like too accurate, so making it say 85 is like seems a decent amount, but that's supposed to be 180, I'm sorry, 160, double it. That's just half the angle that the value is taking. So when you play this, what should happen is since it's 85, right, it's actually, I'll reduce it to something smaller. I'll keep it at 45. So supposedly this has a 90-degree field of vision in this direction forward, which is C. So it's in this direction. We're out of that right now, so it shouldn't even look at us and it shouldn't come towards us also by default, and it doesn't. So what you can do is technically you can sneak up behind the player, but if you go in front of him in his field of vision, he starts chasing you. Now I'm out of his field of vision again, nothing, and I'm in front of it and it starts chasing me again. So it's not just the distance from the thing, but it's whether the player can see me also, the enemy can see me also. So see, I go up, starts chasing me again. See, that's a basic enemy AI. He'll follow you. You can have like shooting scripts and stuff on the thing, as we've done for the player. It's pretty much the exact same for this. You could have it ray casting, you could have prefab shooting, you could have throwing grenades, it could just come and punch you, anything. So this is your basic script really. That's honestly, that's all there is to it. I give you the angle, I showed you the target range, yeah, that's that. Now the only issue with this kind of thing is I can actually demonstrate it to you. Right. So the issue with this is, even though it is goddamn excellent, but now that it can see me, okay, it'll try to follow me. And see, I pass through it because I'm using transform.translate. The enemy can't. So yeah, point being, it's still looking at me, right? Technically speaking, it shouldn't, because there's a wall. If you're trying to make like a stealth game and stuff, for example, I could just stick it here. It's more accurate. At this present moment, the enemy hasn't seen me. And if I go here, it shouldn't know that I'm there because there's a wall in the middle, right? Of course, but it still follows me. It knows that I'm there. That's because it doesn't know there's a wall in the middle. So what one could do instead is basically come here, and after this, like after this final angle thing, the last thing you could do is to raycast. So for raycasting, you do physics dot raycast, and you do transform dot forward. So it's from that position, and it has to be, no, actually it doesn't have to be from the, yeah, sorry, this is the second parameter. First you have transform dot position. It's from this point, which is its own position, forward, that is shooting the ray, and out dot, no, out hit, wait, I haven't, you need to, I could refer to it on top itself. You do private raycast hit, I think it's called raycast hit, right? I think so. I think so. Yeah, I'll just go with it. In case it's not that, we'll figure it out. So yeah, I guess it's raycast hit anyways. Where was I? Yeah, hit. This is done. Yeah, this will raycast. Now after this, what you have to say is, actually I could just stick it here itself. After it raycasts, you could say and hit dot transform dot tag is equal to wall. No, if it's not equal to wall, sorry, then you have to move. So point being that at this point it'll raycast it. If it's within the distance and it's within that angle, it'll raycast from the position of the player itself forwards, and out hit basically returns data about where that raycast ends up hitting. So hit.transform.tag gives you the tag of that object which gets hit with that ray. As long as it's not a wall, you can chase the player, but if it is a wall, don't do anything. So hopefully this works. I mean, that's one thing that I've had slight issues with sometimes. Yeah, as I said, so you can add tags and stuff, right? So just add a new tag, you say wall, save, and yeah, that doesn't add a tag, so you have to go back and do this. So this is a wall at this point. Okay, just saying, I don't have good history with this, so as of now, if I come in front of it, it should not move, and it didn't. Wow, okay, that worked. That's rare. Yeah, raycast is it's a little tricky. So at this moment, just for visualizing what's happening, what you could do is where's the raycast? Yeah, you know. So after a raycast, you could do a debug dot. We have debug dot log, right, to log stuff. So similarly, you have debug dot draw line, which basically draw ray is actually a little better. Use draw ray and use the same conditions as this, I guess. So it's from the same position, it's in this direction, and you could use distance, but I mean, you could use color instead. Okay, color dot red, I'll say. Should be fine. So this allows you to see exactly how the raycasting is happening and what direction it's happening. Because sometimes when you import models, the forward, right, up, and all that stuff gets a little messed up. And it isn't raycasting. That's odd. Why aren't you raycasting? Just for proving my point that it's not really broken. See, it did chase the player. It is chasing the player. It's not broken, and the angle thing still kicks in. Now, yeah, as I was saying, so the issue with raycasting is, as of now, what it does is, yeah, okay. So the issue is that if I pop up here, oh, wait, I'll have to push it a bit. Shit, okay, I'll just restart. Point being, the issue is sometimes, since you're trying to raycast it to check whether it needs to move, a raycast is like completely straight. It's just one single ray. So as long as you're not crossing that ray, it doesn't register you. So I could be, shit, okay, I crossed the ray. Yeah. My point being, I could be like really, really close to it. Technically, I'm still within its field of view. I'm already there. Now, just for final control, I could bring it this close, but I'm fine. But its ray is somewhere here. Here. So as long as I don't cross it, it can't recognize me. But the moment I break that boundary, it'll turn towards me and spin. Why aren't you doing it? Oh wait, sorry. The ray is on the other side. My bad. Okay. So yeah, my point being, you have to come exactly in the center. So that's why I prefer not to use raycasting very often. You have to use it in an appropriate manner. Just check it once and then accordingly move it and stuff. That depends on how you optimize your code, to be fair. So yeah, that's that. We have successfully completed enemy AI. You have a relatively smart AI at this point, which can attack you. I believe in the further sessions, Rastogi is going to handle the health and stuff, so you can understand what the enemy would end up doing in case it sees you. See, this is what I was talking about. Normally, it would just chase me by now, but I have to cross it perfectly at the center and then it sees me. See, it doesn't even continue tracking me because it's still checking. So yeah, that's slightly iffy, but that's what it is. So that's enemy AI, and that's pretty much it for today. If you guys have any doubts, you can, as usual, get back to me. Not that you'd have any. So, see you guys. Ciao.